In this video, we're going to look at properties of parallel vectors and how to find a vector that's parallel to another vector. So we've established earlier in the unit that vectors are parallel when they are scalar multiples. So a vector 1, 2, 1 is parallel to a vector 2, 4, 2 because that vector is twice the original vector. So in general, A is parallel to B if B is some sort of scalar multiple of A. So I've used the scalar k here just to indicate scalar multiplication. And that k value can be any real number. So recognizing that vectors that are parallel are linked by a scalar multiple, we can sometimes be tasked with solving problems to figure out the missing components of a vector. And so here I've given two vectors A and B, and we're told that A and B are parallel. But if you look at vector B, you'll notice it has some missing components. K and L are unknown quantities. Now what you would do in a question like this is really just recognize if they are parallel, there is some scalar multiple that links the two. And so I look at that x component, because that's the component I have in both vectors. And I recognize if I multiply the vector A by a -3, it gets me to the component in vector B. So that must be the scalar multiple that links them. So if I use that same scalar multiple to find the other values, then what I realize is that k must be equal to -1 times -3, so 3, and L must be equal to 4 times -3, or -12. So I can solve for missing parameters that way. It happens quite often that we'll also need to find vectors that are parallel to another vector but possessing some sort of different property, usually a different magnitude and potentially going in the opposite direction. Here I'm saying let's find a vector in the same direction as vector W, which is 2, 1, -3, but this new vector has to have a magnitude of 50. Now the way that we can do that is by actually finding a unit vector in the direction of W. So we've said previously that the unit vector in the direction of any vector can be found by taking the original vector and multiplying it by 1 over its magnitude. So that just divides away the magnitude until you scale it back down to a size of 1. A quick calculation for the magnitude of W tells me that the magnitude is √14. So therefore, a unit vector in the direction of W can be represented as 1 over √14 times 2, 1, -3. Which I could rewrite if I wanted to as 2 over √14, 1 over √14, and -3 over √14. But of course, that vector is a unit vector, so it has a magnitude of 1. I want one that has a magnitude of 50. So I could say that a new vector, z, this could be the vector that I'm actually looking for, and that vector has to be 50 times the unit vector in the direction of W. So by finding the unit vector in that direction, I've ensured that I'm making the vectors parallel, and in order to get the magnitude right, I just have to do scalar multiplication to sort that out. So by multiplying the components of that vector by 50, I end up with my final vector, z, being 100 over √14, 50 over √14, and -150 over √14. So that would be my vector in the same direction as W with a magnitude of 50.